So keeping the plane lines discuss chesinapudu, do you remember the first basic position what we assumed is line parallel to both the planes. But keeping a plane parallel to both the reference planes is not possible. Keeping a plane or a surface parallel to both the planes is not possible. So it will go to first initial position when the plane parallel to HP and perpendicular to VP. Observe this condition. Assume this as a rectangular plane, rectangular surface, and it is kept in a position parallel to HP and perpendicular to VP. The entire surface is parallel to HP and it is perpendicular to the vertical plane. So when this the condition, if you see the top view, what you can see? Top view and for this condition.
Line.
The complete surface, or the complete plane. You can see this, the true shape, the exact shape of the surface. When you see the front view, a simple line. You can't see the surface. Surface contains no position orientation law.
No, sir.
No, you can see a line. So when the plane is perpendicular to vertical plane and parallel to horizontal plane, you can see the true shape of the surface in top view, and in front view you can see only a straight line. The same case when the line is parallel to vertical plane and perpendicular to HP. See here, the entire surface is perpendicular to the ground and it is parallel to vertical plane. So if this is the condition, in front view, what you can see?
Surface.
The complete surface and its edges, every detail can be seen, shape and size. But in top view?
On line.
In top view, you can see only a line. Front view, the complete surface, and top view, a line. So for plane problems, we have to decide this one first. In which view we can see the true shape of the surface? True shape means the complete shape. When the plane is parallel to horizontal plane, we can see the true shape in top view. When the plane is parallel to vertical plane, we can see the true shape in front view. When the line is inclined, to HP, this is the conditions here. The line is inclined to HP and perpendicular to VP. Second condition. We can see the true shape only when you see the plane perpendicular to this surface. Perpendicular to the surface, choose true shape convert. See here, when the line is inclined to vertical plane inclination add cheskunte veltundi shape. Can you see the true shape now? కనిపిస్తుందా?
నో సార్ తగ్గిపోయింది సార్.
ఈ రెండింటి మధ్య డిస్టెన్స్ రెడ్యూస్ అవుతుంది. 2 points రిమైనింగ్ ద సేమ్, బట్ ఏంటంటే యాక్చువల్గా ఉన్న స్క్వేర్ అనుకోండి, గోయింగ్ ఆన్ ఇట్ ఈస్ బికమింగ్ లైక్ ఏ రెక్టాంగిల్. సో ఈ హారిజాంటల్ డిస్టెన్స్ కంప్రెస్ అవుతుంది. సో యూ కెన్ సీ ఓన్లీ ద reduced shape or the compressed shape of an object. So when the line is on the surface is inclined to vertical plane, top view a simple line, front view reduced shape. Rundu views lo you can't see the true shape of the surface. So for this there is a procedure which we are going to follow. Similarly, when the line is inclined to horizontal plane, front view you can see a line, top view reduced shape, apparent shape or reduced shape of the surface. This is the second condition. First condition is the surface is parallel to one reference plane and perpendicular to the other. Second condition is plane is inclined to one surface and perpendicular to the other. The third condition is when the surface is inclined to both the reference planes. This is the condition. Inclined to horizontal plane and also inclined to vertical plane like this. So In both the views, we can see two reduced shapes, but not the true shape of the plane. So, before going to the inclinations, first let us go through a problem when the surface is perpendicular to one reference plane and parallel to the other. So I'm typing the first problem in chat box. Go through the problem. Sheet number 9. Problem number 1, and this 3 bits are there, A, B, C. So first is an equilateral triangle of 50 mm side has its plane parallel to VP and 25 mm away from it. Means the surface is parallel to VP and indicating perpendicular to the other. So definitely condition in name, if the surface is parallel to one reference plane, it is perpendicular, must and should, it must be perpendicular to the other, even though the condition is not given. Oka reference surface ki parallel aniste, it implies it is perpendicular to the other reference plane. So the surface is parallel to VP. So when the surface is parallel to VP, we can see the true shape in front view. In top view, we can see a line. So line code a distance ichcharu. It is at a distance of 25 mm away from it. So in top view, the line is at a distance of 25 mm from XY line. So above or in front of most of the cases we discussed. The default is first angle projection, assuming the surface or the object is in first quadrant. Means always drawing front view above XY line and top view below XY line. So first to draw XY line. Draw XY line. Name the problem number 1 on the right hand side top corner. And now, as in both all the three cases, the surface is parallel to vertical plane. So you can see the true shape of the surface in front view. So we must start the problem with front view. So a view like a true shape kanipistundo, we'll start the problem in that particular view. So for this problem, we must start it with the front view. So in front view, draw chese mundu, check the other conditions, how it is oriented. So how it is oriented means, even though it is parallel, it may be of different kind of orientations. Surface exactly it may be at different orientation. So along with the angle, we should also know the orientation of the surface. So orientation of the surface, the condition is given. Draw the projections and obtain its traces. Actually, traces are not there in our syllabus. No need of drawing traces. When one of its sides is perpendicular to HP. So front view lo triangle draw chesinapudu initially draw with one of the sides perpendicular to XY line in front view. Perpendicular to HP means in front view the line is perpendicular to XY line. So like these the points A dash, B dash. So equilateral triangle don't use the protractor, use compass. This side length equal to 50 mm given in the problem. So take compass radius equal to 50 mm. A dash as center. Draw an arc. B dash as center. Intersect this arc. We'll get a point. Name this point as C dash. Join A dash C dash, B dash C dash. We'll get more accurate way. A simple way and more accurate. And coming to the distance of the surface from the horizontal plane, it is not mentioned in the problem. Problem like a condition ichara? No, the distance of the plane from the horizontal plane is not given, so you can maintain any distance, but not on xy line. Maintain a minimum of 2 to 3 centimeters from xy line. So about 2 to 3 centimeters from xy line or point B dash. From B, draw a vertical line of length 50 mm. You get the point A dash. Now this is the front view. So in front view you can see the true shape. Condition icharu A with one of its sides perpendicular to HP. One of the sides in front view perpendicular to XY means the line is perpendicular to HP. So with this we completed the front view. Top view. Draw the projections from each and every point from the front view. Draw the projections from each and every point from the front view. On top view condition, it is given as the surface is parallel to vertical plane and at a distance of 25 mm from it, away from it. So at a distance of 25 mm below xy line. Draw a parallel line. As in top view, you can see it as a simple line. What are these points? C, A, B. So in top view, you can see a simple line. And coming to this, when you're seeing exactly from top in this direction, when you're seeing the triangle in this direction, what we can see? We can see only the edge AC. Is it or no? We can see only the edge AC. All the remaining lines are hiding, which implies when you're seeing from top, only point A is visible, point B is hiding. So we'll represent the point B within the brackets, showing that it is a hidden point, but overlapped with point A. So this is the way of representing the top view. So coming to the dimensions, so in problem the dimensions are given as is at a distance of 25 mm away from vertical plane and side of the equilateral triangle. So this is how to represent when a surface parallel to vertical plane and perpendicular to horizontal plane. Now rid of this arrow representation. మీకు ఏ స్టేజ్లో డౌట్ వచ్చినా సరే ఇమ్మీడియట్గా అన్మ్యూట్ చేసి క్లారిఫై యువర్ డౌట్స్ while I am explaining. Don't wait till the end of the problem or after the class. You can unmute your audio and clarify your doubts whenever you are having doubts. Is it clear? Drawing the front view on top view when the surface is parallel to vertical plane and perpendicular to horizontal plane. And next condition, point B. This is the point B. When one of its sides is parallel to HP, when one of its sides is parallel to horizontal plane. So the initial figure, the same condition, that is the plane is perpendicular to horizontal plane and parallel to VP. The plane is perpendicular to horizontal plane and parallel to VP. So you can see the true shape in front view. So in all those three problems, A, B, C, we can see the true shape in front view, but with different orientations. Now, parallel to HP, one of its sides is parallel to HP. So, the initial side, AB, A dash, B dash, draw it parallel to the horizontal plane. And from A dash has center 50 mm radius, B dash has center with 50 mm radius, draw the indicating C dash. Join A dash C dash and B dash C dash. Initial front view. The front view when one of its sides is parallel to HP. So parallel to HP means parallel to XY line in front view. So for getting top view, draw the projections from A, B and C. So mark these points A, C, B. When you see a triangle from top view, what you can see? When you see a triangle exactly from top view, we can see the edge AC and CB. Is it or not? Then this is the orientation, allow me. So top, when you're seeing from top, you can see only these two edges. The bottom edges are hiding. See here when you're seeing like this, you can see only the two edges. Point C, B, A are visible. So means we are seeing the edges CA and BC. Means even though it is looking as a straight line, these points are A, CB. We are seeing a line AC and CB in top view. So this is the way of drawing. When a surface is perpendicular to horizontal plane and parallel to VP, with one of its sides parallel to HP. Dimensions are must for each and every problem. 25 better. So it's not mistake, but actually I want to draw one more problem here. That's why I raised this. Represent the dimension. 25 or any one represent the dimension on any one of its sides. 50. Next, coming to the third problem, with one of its sides is inclined to the HP and at an angle of 45 degrees. It's not 450, it is 45 degrees. So first draw the line AB with 45 degrees inclination. Draw a line AB with 45 degrees inclination. So these are the points A dash, B dash. Now from A dash as center, draw an arc. B dash as center, draw an arc. We'll get the point C dash. So the triangle, when one of its sides is inclined at 45 degrees to horizontal. Now, draw the projections from each and every point from top front view. Projection from A, projection from B, and projection from C up to 25 mm below X line. So on this line, what is this? Projection from C. C, A, B. C, A, B. So these are the 3 points. Now, when you are seeing from top, and this is the orientation, and you are seeing from the top, what are the visible points? What are the visible points?
C dash, B dash, CB.
P, B are visible, point A is hidden. So actually, when you see from top only, we can see the edge CB. We can see only the edge CB. And BA and CA edges are hidden or overlapped with CB. Finally, dimensioning. So this is a condition when the surface is parallel to vertical plane and perpendicular to HP with varying orientations. Next. Go through the second problem. A pentagonal lamina of 30 mm side has one side in HP. Its surface is inclined at 45 degrees to the HP and is perpendicular to VP. Draw its projections. A pentagonal lamina of 30 mm side has its one side in HP and its surface is inclined at 45 degrees to HP. Problem number 2. The condition is given as shape is a pentagon, surface is inclined at 45 to HP and perpendicular to VP. So this is the orientation. And the surface is perpendicular to VP and inclined to HP. So in which view you can see the true shape of the surface? Any of you? In which view you can see the true shape of the surface? Front view or top view?
Front views.
In front view, you can see a line. Top view, only the reduced shape. So, rendu views
At an angle.
Yes, at an angle. So, rendu views you can't see the true shape. So, these problems, inclination problems, we will first make the surface parallel to HP. So, first one problem identify cheyalsindi whether the surface is inclined to HP or VP. As the surface is inclined to HP, the first initial assumption is making the surface parallel to HP. The first assumption is the surface is parallel to HP and perpendicular to VP. So we will draw the first condition in this orientation. Assuming the surface is parallel to HP and perpendicular to VP. So when the surface is parallel to HP, in top view we can see the true shape. Is it? In top view we can see the true shape. In front view we can see it as a line. So we must start the problem from top view. So top view draw చేసేటప్పుడు orientation. So orientation ఇచ్చినప్పుడు first we should check the condition. ఎడ్జ్ కానీ కార్నర్ కానీ బేస్ చేసుకుని ఇంకొక డేటా ఇస్తారు. See here, one side is in HP. So whenever the condition is given in this way, with one side is on reference plane or parallel to reference plane. మీరు ఎప్పుడైనా సరే ఈ కండిషన్ అబ్జర్వ్ చేస్తే, that is when one of its side is parallel to reference plane or on reference plane. So what is the condition here given? One of its sides in HP. So as one of its sides in HP is given, we must draw the pentagon orientation with one of the sides perpendicular to XY line in top view. So one side on or, so first of all we decided to start the problem from top view. Top view lo we have to draw the pentagon. So pentagon ఏ orientation లో draw చేయాలి? For deciding that, we should see the next condition. One of the side is in HP. So whenever you identify this, draw the pentagon with one of the sides perpendicular to the XY line in top view. Perpendicular to XY line in top view. As the distance is not given, we can maintain any arbitrary distance. Now, already we discussed how to draw the pentagon while discussing the involutes. Gutunda? How to draw a pentagon? First, take the protractor. Let these two sides be A, B.
Perpendiculars here.
108 degrees. So, draw the two lines. Draw the two lines at 108 degrees. These two angles are 108 and 108. So, after drawing two inclined lines at included angle 108 degrees, take the compass. Take the compass with AS center and length equal to, here the pentagonal lamina is of side 30 mm. So AB equal to 30 mm. So with 30 mm AS center, draw an arc, BS center, arc. Let these points be C, E. Now with the same radius, CS center, arc, ES center, arc. You'll get the point. So means you are maintaining equal sides. Join DC and ED. We'll get the pentagon of required dimensions. So first draw the with 2H pencil. Only highlight up to C. Here, మీరు erase చేయొద్దు, extra ఉంటే కనుక ఉంచేసేయండి. As for me, there's a provision I am erasing out on board, but don't erase on drawing sheet. The extension line, if you are getting more than the line, leave it. Now, this is the top view. Now, project each and every point from top view to front view. Draw the projections. So if we draw it exactly, we'll get the same projection line from C and D. We'll get the same projection from C and D and same projection from B and D. So, ekkada varaku project cheyali? The distance of the plane from horizontal plane ichara, as it is given, one side in horizontal plane. The condition is given as one side in horizontal plane. So we must project it up to XY line only. Means on HP. Assuming that the initial front view is on HP only. Means on XY line. The front view is on XY line. So what are these points? A dash, B dash, C dash, D dash, and E dash. A, B, C, D, and E. So when you're seeing in this direction, towards the XY line, always remember the viewing direction must be towards XY line. Points B, C, D are visible. A and E are hiding. So represent A and E within the brackets. Is it completed problem?
Inclined at 45 degrees.
Yes. The surface is inclined at 45 degrees. So what we are doing is, actually, this is the position of the surface. The surface is resting with one of its sides on horizontal plane and the surface is inclined to HP. What we assumed is, we assume this inclination 0. We are assuming that the surface is resting on HP. And based on this, as true shape is visible in top view, first we completed top view. And then respect to front view, as the assumption is resting on horizontal plane, we have drawn this line on XY line. Now rotate this to 45 degrees. So rotate just same on the front view. Line is rotating. In front view, what you can see? A line is rotating. Initially it is on XY line, and rotate this line for 45 degrees and redraw the front view. The front view what we draw now is a line on XY line. Now rotate this front view for 45 degrees and redraw. So redraw cheyalante, extend this XY line. So this is XY line. Extend this XY line. Actually, you can draw by overlapping on this figure also, but you don't get a clear picture. It looks clumsy, or overlapping lines, you don't get the final clear picture. So what you have to do is draw the second step here. So redraw the line, measure the length AD, or first draw a line for a length of inclination of 45 degrees. Draw a straight line inclined at 45 degrees. So when you rotate this for 45 degrees, point A and B, is it on XY line? So name this as A1 dash, B1 dash. Name those 2 points as A1 dash and B1 dash. Now measure the distance from A to C with compass. With compass, measure the distance from A to C. A center, draw with the distance. You get the point C1 dash, E1 dash. Next, measure the distance from A to D. Measure the distance from A to D. With A center, draw R. To get the point D1 dash, T1 dash. Highlight this line only from A to D, leave the remaining line with 2H. Highlight this line only from A to D, means with HB, and leave the remaining line with 2H. Now, this is the position when the surface is inclined at 45 degrees to HB. Now, the respect to top view. What is the top view? When it is inclined at 45 degrees to HP. So, top view kavalante, draw the projections from each and every point from front view. Draw the projections from A1, B1, C1, E1, D1. Draw the projections from each and every point from front view. And locus from the previous top view. Locus means a line parallel to XY line. From A, B, C, D, E. Draw the projections from A, B, C, D, E. Now, mark the respect to intersection points. Means projection from A, be careful. Projection from A, locus from A, A1 and A intersection. Name this point as A1. Similarly, projection line from B, locus from B, B1 dash B. Name this intersection point as B1. Projection from C1 dash, locus from C. Name this intersection point as C1. Projection from D, D1 dash and D. D1. Similarly, here, E1, A1, B1, C1, D1. So mark the respective intersection points. Projections from A1 dash, B1 dash, C1 dash, D1 dash, E1 dash, and draw a horizontal lines from the previous top view A, B, C, D, E. Now join these respective points. AB, BC, CD, DE, A, B, C, D, E. So this is the final top view. Compare these two shapes. This we can see a regular pentagon, and when it is inclined, we can see as if it is a compressor, a reduced shape. It is not a regular polygon. Only if you measure, only AB is of the given 30 mm osni, and remaining all other sides length will be changing. It is not equal to 30 mm. Do you have any doubts in this? So when the surface is inclined to any reference plane, we are not drawing it directly. We are splitting the problem into two. First stage, assuming the surface is parallel to the given reference plane. And then applying the condition as given in the problem. The problem condition given is the surface is inclined at 45 degrees to HP. So rotating this line for 45 degrees and completing the problem. So this is the procedure which we have to follow for applying inclined to any reference plane. In doubts on the Do you have any doubts in this? If you have any doubts, unmute your audio and clarify. Or else I will move on to the next problem. Problem number 3. Last problem for today's class.
సార్ వాళ్ళకి ఆపేయండి సార్ చాలేదు
Today class మనం ఆల్రెడీ హాఫ్ అన్ అవర్ లేట్గా క్లాస్ స్టార్ట్ చేసాం. Just let us complete one more problem. Problem number 3. Problem number 3. Hexagonal lamina offside means the shape of the surface is hexagonal with side 25 mm, has a corner in VP. Previous problem in edge, and here a corner in VP. The surface is inclined at 40 degrees to the VP and perpendicular to the HP. Draw its projections. So the surface is inclined to VP and perpendicular to HP. This is the orientation. The surface is perpendicular to the HP and inclined to VP. So what is the first step? As the surface is inclined to VP, make it parallel to VP. Make it parallel to VP. Now, we can see the true shape in front view. We can see the true shape in front view and top view as a line. So we may start the problem with front view as a hexagon. Draw XY line. Draw the front view as a hexagon. So hexagon etla draw cheyali. Again check whether it is corner based problem or edge based problem. Previous problem is edge based. When it is an edge based, the condition is one of the edge must be perpendicular to XY line in initial view. Last problem chesam. Last problem emundi. As one of its sides in HP. In HP means parallel to HP. See, two conditions ela ichina sare, we will draw with one of the sides parallel to XY line, perpendicular to XY line in the initial view, whether it may be front view or top view. Now, in this problem, we'll starting the problem with front view, and it is given as a corner on HP. So, no need to draw the side perpendicular to XY line. Especially for hexagon, you must draw it with two of its sides parallel to HP. So, at draw hexagon, there are two options. We can draw the initial view in this orientation, or we can also draw the hexagon in this orientation. Both are hexagons. So, when the problem is of edge-based problem, one of the edges on the reference plane or parallel to the reference plane. As we have to draw the edge perpendicular to XY line, we will prefer this orientation. Otherwise, if it is a corner based, we will draw the hexagon as in the second orientation with two of its sides parallel to XY line. How to draw hexagon? I think we have not discussed this one. First, let us discuss how to draw a hexagon. So, hexagon ki best method is easiest. As the side length is given as 25 mm, draw a complete circle with 25 mm radius. With 25 mm radius, draw a circle with 2H pencil as light as possible. Now, as we require the hexagon in this orientation with two of its sides parallel to the XY line, draw a horizontal diameter line. This is also with 2H as light as possible. No need to show this line. Now, take the compass with 25 mm radius. With this diameter endpoint as center. With this as center and 25 mm radius, draw an arc on both the sides of circle. Similarly, with the other endpoint as center, draw arcs on both the sides of the circle. If we join these with the straight lines, we'll get a required hexagon. Simple way, no need of any protractor or any measuring any angles, only by using compass. I'm repeating. Shall I repeat this? I think you are having the video recording. You can go through the video recording. First, draw the circle, and as you require, two of its sides parallel to XY line, draw the horizontal line. With initial point as center, horizontal diameter, first end point as center, draw two arcs with 25 mm radius, the given side length. Similarly, from the other end point as center, same 25 mm radius, draw two more arcs. We will get hexagon. Only hexagon to be drawn with highlighted. The circle and the diameter line must be as light as possible, as those are only for construction. Now, name the corners as A dash, B dash, C dash, D dash, E dash, and F dash. Now, for drawing its front view. So, front view draw chesinapudu, it has given corner in VP. So, corner in VP means, initial we are assuming it as parallel at the same time. In VP condition nature kabatti, its respective top view must be on XY line. Its respective top view must be on XY line. So project each and every point only up to XY line. So we get the same projections from B, F, C and E. C dash, E dash, B dash and F dash, and these points are projection from A dash. So this is point A, B comma F, D E, sorry, C E and D. So this is the top view of the line on XY line as one of the corner on VP. One of the corner is on VP. We'll draw the top view on XY line. Next, the surface is inclined at 40 degrees to vertical plane. The surface is inclined at 40 degrees to vertical plane. Redraw this line with 40 degrees means draw a 40 degrees inclination line to XY. XY की 40 degrees inclination line draw chasing. Mark this the first corner A. Let it be A1. Next, measure the distance from A to B. Measure the distance from A to B. A as center, mark this point. B1, F1. Now, measure the distance from A to C. A to C. A as center, draw the arc. This is C1, E1. Measure the distance from A to D. A as center, draw an arc. This is the point D1. Means we are drawing the same line with 40 degrees inclination. And highlight the line only from A to D. Highlight the line only from A to D. Now after getting the top view in the required position, that is the surface is inclined at 40 degrees to vertical plane with a point on vertical plane. See here, point A on vertical plane. Previous problem observe cheyandi. There are 2 points on vertical on XY line means the complete edge is on the ground. 2 points on the observe cheyandi. Pentagon problem now. 2 points. Point AB is on the ground. Means it is resting with the edge AB on the ground. And here only corner A is on the vertical plane. Now draw the projection from each and every point. Projection from A, B and F, C comma E and D1. And D1. Draw the projections from each and every point from this. And locus line means a parallel line to XY line from the previous front view. From the previous front view. That is mark the respective intersection points. Mark the respective intersection points. That is projection from A1, locus from A dash. This is A1 dash. Projection from B, locus from B dash. B1 dash. C, C1 and C dash. Next, D, D1 and D dash. D1 dash. Projection from E1 and E dash. Projection from F1 and F dash. F1 dash. Join all these points with a straight line in the same order. A, B, C, D, E, F. Join AB, BC, CD, DE, EF and FE. Be careful, these projections lines must be as light as possible with 2H so that the final projection is highlighted. మీరు కనుక మొత్తం HP పెన్సిల్తో డార్క్గా డ్రా చేస్తే you can't differentiate the or identify the final projection shape. So figure neatగా ఉండాలి అంటే these projections and the construction lines must be with 2H pencil as light as possible and only the final projection must be drawn with HP. Coming to dimensions, only the 2 dimension values are given. The inclination of the line 40 degrees and side of the hexagon, any one side. 25. So this we completed the second problem. From next class we'll discuss the problems when the surface is inclined to both the planes. Then we want to draw the third step also. One more additional stage we're going to get. So if you have any doubts, unmute your audio and clarify.